Good morning, everybody. Well, I got here on time this morning as far as my watch, but I noticed just when I was looking at the whole screen that it on the live it said GMT time, so I'm on Central Time, Daylight Central Time in Texas. And anyway, boy, I use that word a lot. The today's subject is brainstorming, and in the old days, I used to spend a lot of time on the road, and so I had a lot of time to brainstorm. Uh, I'd write something down and think about it and work at it, and so there was a whole lot of consideration building things that I made. Back then, I was focused, on restaurants, different pieces of equipment, and had the opportunity to make all that equipment fit into different areas. And then, of course, plumbing and electrical and the whole 9 yards, and figuring out things, how to get it through the door sometimes, rigging stuff to get it through the door. But you have a 36-inch hole and you have a 36-inch piece of equipment. Well, that won't fit. You have to back it off at least a quarter inch where you have an eighth inch on each side. And if it's out of square, then you still might have a problem. So the rule of thumb, we always gave an inch, and that way you have a half inch on each side when you put it in there, just like anything else. So that's one of the reasons that when I'm brainstorming about working with a piece of equipment, I do a mock-up, and it just makes it easier. So you can get an idea and make sure that whatever package you're putting together is going to fit in that package. The finding nominal sizes that you can reduplicate. Most of the things that I did were custom, and I wasn't in the manufacturing side of it, although I did deal with a lot of manufacturers, and would get ideas from different owners of restaurants and the people that actually worked in the kitchens. And I'd always ask them, what do you like about this piece of equipment? And they'd tell me all about it. They'd say, "Man, that's one of the best pieces of equipment I've ever operated." Or they'd go, "Well, it works good, but it's hard to clean." Okay. And so the brainstorming side of it is talking to people that actually use whatever it is that is in there. And that's one of the reasons, when you get your prototype out and you have your few select people that you use your prototype, and you go into beta testing. And a lot of people have been beta testing the simple Bedini schoolgirl motor, they call it, for a long time. And so the Bedini, when you start experimenting with different configurations, the very, very interesting circuit. And I still don't think I've configured it every which way possible, but I've searched, what that's out. And that's one of the great things about doing this. Most of the time I've been very private about this energy, and you know, people say, "Oh, it's just a a pulsed DC waveform," and the yeah, that's true. But there's phenomenon there, and when I found the parametric phenomenon off the Bedini wheel, I went, "Wow, okay." Finding the uh, um, asymmetrical solution, and most people when they're building motors, they want it to be balanced, and I've chosen to go to the route of an unbalanced system, and the feedback off the unbalanced system is what I'm looking for. One of the key things that I found as far as brainstorming, this is steel wire, and it's enamel coated. It's about 24 gauge wire, and it's hard to find this wire in lengths over 150 feet. Okay. Got a feeling there's a pretty good reason for it. This is actually used in the floral business for floral ties with flowers and things. And we were somewhere and I saw a 150-foot roll of this, and I go, what you get when you make a coil out of steel and copper? Okay. And so we don't know what kind of wires the masters back in the day used. Were they just like us and used what they had? There's a lot of baling wire and things like that. And but I just want to give food for thought. I actually haven't wrapped a Bedini with this yet. Of course, going to, but I have done the jewel ringer product, and this is the steel wire, and this is a hollow core. All this is a piece of PVC with the caps on the end of it. And what I did is I wrapped it very carefully all the way across it until it got to the end. Okay. And so the wire that's bent is my start coil. So I know that that's right here. Okay. I know that the start coil that's up underneath this number 10 gauge copper stranded wire is right up underneath there. And then the unbent end, the uncrimped end is the wire that goes all the way here. And when I got finished, drilled a hole and sent it down the center. Okay. And then I wanted a center tap. Okay. And I haven't played with this in all the configurations because this top coil is wound the same way all the way across. Instead of winding it like you would a transformer, you actually start here in the center and on this top layer and let it come out all the way across. And that sets up a wave pattern that you're getting on the feedback. But as you can see on my video that I've had posted for a long time, nobody's really talked about it. Yeah, it's just a transformer coil by Filer, and it's hooked up just like that. Okay, and you can hook it up backwards, where the big wire is, the little wire is, and it'll still work. And one way it works with lots of power, and the other way it works with reduced power. But you have to go with a much bigger resistor when you're using this coil, because if you're only around the range of um, uh, anywhere from 75 to um, 1,000 ohms resistance, the you can get it to oscillate and blink and do other things. The coils, I mean, the variable resistor that I ended up using uh, is a lot more resistance, and so the low side of it is about 3,000 ohms resistance, and the high side of it, I think I was at almost 20,000 ohms. So to get the effect, but I could get the frequency, and I hadn't measured the frequency off this, but it's a brainstorm, okay? And but I was very excited how very little energy it had and the effects of it, and that's the reason I have it posted up there. This needs to be explored more, and the simple combination of steel wire, and of course this is stranded number 10 gauge electrical wire, just black insulation on top of it. But one of the things I found is when you're building motors, that you need to design it to carry the amount of current that's going to be carrying. And the testing what they do basically commercially on a 120 volt motor, I've noticed that nearly everything ohms out at about 6 ohms. And then for 220, I've noticed it measures out at higher ohms. So you need, just check that out. The rule of thumb is to what they do commercially. The parametric energy is what they avoid doing because they're working with a grid system, and as they're running motors, as you're running motors in your household, the motor that runs consistently all the time is my swimming pool pump motor, and I have a 2-speed, and the 3,200 RPM is what it, is high speed normal pumping, what it's designed to pump. And then you click the switch and it drops it down to half of that, about 1,800 RPM. And it, uses less current. Funny thing about it, it gets hotter running slower than it does running at full capacity. But it runs consistently, and that's my first motor that I'm replacing is a motor with this new technology, and I want it to be off grid. And what I mean by that, when I say off grid, not connected to AC mains, and so that's my first place that I'm going is running swimming pool pump motor. Now, one of the things in my system, I use ultraviolet light in there, and the ultraviolet light is pretty high amperage ultraviolet light to sanitize the water as it runs through the filtration system. And so anyway, I'd like to be able to run that light too, and have those two things off the grid. I have come up with other technologies as far as pumping water to pump the same amount of volume with it, which That's really important to somebody that's maintaining swimming pool is getting that down to where in the area of 40 watts total consumption power, and the that's my brainstorm as far as this technology is the swimming pool business. The that in itself is a big chunk, and then of course there's spinoffs from it once you really learn to do it. Will my system be self-contained? Probably not. What I mean by that is that integrated with solar power, integrated with wind power. But I believe that you can do it station by station. And then for heating and cooling swimming pool water, of course, heat pump technology has been there, and that's pretty simple technology itself. I work with ice machines a whole lot, understand refrigeration, and but taking the horsepower of what it takes to really do a heat pump operation, most people don't consider. They look at what the compressor is and look at what the condenser fan is, and the it's a brainstorm. You can take spinoffs from this technology, but the one thing about it is it's valuable when you really understand it and you get your licensing to install this. Whether you have somebody that's already licensed, I have a master electrician. She can write off on any job that I do, and she oversees it and checks it out. And so I used to be the one that went and got all the licenses and carried lots of insurance and things for the companies that I worked for. And so so I hire people that have the licenses to when I do installations to handle that part. It's new technology, and I look at each thing one thing at a time. That's the way I do my projects and development. But there's a brainstorm that happens when you got it. I mean, I've been working at this for a long time and trying to go, okay, I'm using it on my house, and this is what I can do. I'm not off the grid. Don't intend to be off the grid. I would like to always stay uninterrupted. You can do that with just general generators. So basically I'm looking for higher Q factors than what's out there, and I'm not going to sit there and blow smoke and say, hey, there's free energy here. But if you're not connected to a grid and you have a self-contained unit, and it ends up costing you money per unit, so the rural applications and pumping water is really important. And we know how to do that with basic sine wave batteries and motors and pumps, and been doing that for a long time. But we can sure make it a lot more efficient, and that's the brainstorm that I have in my area. So I'm focused in on just something simple: is a good swimming pool, a pump motor that's more cost efficient, than what's out there in operation, because the swimming pool motor, instead of turning it off and turning it on, it should run continually, in my opinion. The continuous circulation, in my opinion, my humble opinion, is in that area. Then, being a chemist and everything, I've learned how to take care of a swimming pool a long time ago, and I've worked with all kinds of different waters and those type things. So that's a whole industry in itself. And I've got a friend, Bart, that has worked on some of the coolest swimming pools around. He's certified. It's a whole certification process to get through, and he very experienced with swimming pools and knows a lot about it. He did. And I have another friend that he was raised in the swimming pool business, building swimming pools, and that's always kind of interested me, because I do a lot of work with fiberglass, and the pool that I have is an in-ground pool, but it's fiberglass and lined. It's not a drop-in fiberglass type. It's fiberglass. One of the things I can tell you is that I've had liner pools, which were excellent pools, and about every 10 years you had to go get a new liner and put it in there, but it really wasn't very expensive. You had to spend for the liner. I was able to buy them pretty cheap. The actual cost of the liner for a 27,000 gallon pool, last one I replaced, was just a little over $1,000, and for the thick liner, and man, it weekend and had it installed no problem. So I like the liner pool over the gunite pool. I've had gunite pools, and about the same thing. About every 10 to 15 years, you have to drain the pool out and redo the liner. But man, this fiberglass line pool, very, very reasonable with chemicals, and we'll get into more to that. This is the first pool that I've had attached to the house, and we used what was here, and I'll show that later on to you. But we found the right polycarbonate roofing material that reflects the UV rays. We were in the pool all day yesterday, okay, and it was bright sunshine and everything, and no sunburn or anything. And then also it operates much cooler than what we had, and I'll get into showing you those things. But to me, this technology offers a lot of advantages in just the swimming pool area. Everything from, like I said, using heat pumps, using water pumps, the UV lighting, all the way down to the chemical dispensing system. And there's a lot of people out there that do a lot of different things with vortex technology. The professional swimming pool people like Leslie's in our area, they pretty much use the same technology all the way through. So I think short time there's going to be some really cool breakthroughs just dealing with swimming pools and water treatment, and I want to be on the cutting edge of that. Another brainstorm is greenhouses, pumping water with greenhouses and those systems. And they use a bubble lift system that, very, very inexpensive. And basically done with PVC pipes, and the raising your own food. People just, when you always do what you've always done, you'll always get what you've always got. Okay. So if you always do what you've always done, you'll always get what you've always got. So people do the same thing over and over and over again. It's related to my story about the little girl and her mother cooking a pot roast. And Mama, why do you cut the end of the pot roast off? And they finally get to the great grandmother. And she says, "Oh, my pot wasn't big enough." You know, we're been a tribal society for a long time, pretty much done the same thing. Even with the internet, we still do things the same way that we do. Yes, there's been improvements, but man, as we get the consciousness of several people working on these different problems, we can really have some breakthroughs privately. And I've always been on the cutting edge. Yesterday, uploaded a video of a good friend of mine. Y'all pray for him. He's had a stroke. But anyway, John came up to me one day when I was working at the boat shop, and he goes, "Bill," he says, "I want a boat. I know what kind of boat I want. I want a Ranger." Okay, got one out there. Go look at it. And he said, "Yeah, I've already spied it. That's what I want." So the only thing is, I want a motor that will kick some chicken. I said, "Well, I can hook you up there. I know a lot about that." And so anyway, I didn't want him to hurt himself because I've worked with high-speed boats before. My boat, when I was guiding on Toledo Bend, I could be at the Pendleton Bridge drinking coffee and get a call. We didn't have cell phones back then, okay? And my wife would say, "Hey, I'm up, I'm ready to go fishing." And anyway, I could make the 22-mile from Pendleton Bridge down to Milam pretty quick. I don't want any of you guys to think, but the guys that knew my boat, you know, they go, "I don't know what he's running on that. The Callan says 150, but man, he is kicking some chicken." And yeah, the two-stroke motors, I was not too much. I can't make a two-stroke motor down. The reason for it is on a two-stroke motor, when they were manufacturing, you can't even buy them. The only people that run those motors anymore are is Evinrude, and they came up with a great technology to not have any smoke on a two-stroke motor, which, you know, pollution, carbon footprint. And they introduced it in 2000. They hadn't proven it all the way, and the injector is right on the head. Well, if you have one of those motors, I'm the guy that can straighten that out and make it a good motor. I got the parts for those Fitz motor. Evinrude calls it E-Tech now. And but they tried different softwares and stuff after it came out, and they were trying to, you know, really get it down. And so the E-Tech Evinrude is about the only motor out there. I run Yamaha back in the day, and the reason I like Yamaha over Johnson or Evinrude or Mercury was because the power head on it, on a 156 cylinder power head, and they did the same thing with Johnson, Evinrude, and Mercury too. But you know, they had one block, one piston size, same rods, everything else. The block was the same, and they designed it to run at 225 horsepower and with the different gear ratios. So once you learn, you know, about tuned exhaust, I'd change out the exhaust system and put a tuned exhaust on it to get the horsepower up, and that alone is huge. Change out the reeds, and went from the metal reeds to a fiberglass reed, and they react quicker, seal off tighter, and just right there you get a lot of horsepower. And then, of course, you go to big bore carburetors, okay? And then understanding carburation and how to do that naturally aspirated. I can make a naturally aspirated engine run like there's my kitty. Yeah, my angel cakes right behind me. Come here and introduce yourself. Anyway, then when you're using oil injectors, then with the fuel, since you have an increase of fuel through the carburetors and volume, then you have to put more oil in there. And actually all that was just an arm on the Yamaha fuel injection system. And I've customized a bunch of those motors in my area for people, and they go, "That's one of Bill's motors." Yeah, that's one of Bill's motors. I've always liked that edge, and then the guys that want it and understand it and won't hurt themselves with it. I mean, there's a lot of difference driving a bass boat at cruising along at 45 to 60 miles an hour. Without the bullet head, I started cavitating at around 86 miles an hour on water, and so but I did have some fun. The tack, I mean, not the tack, but the speedometer had a setting on it that you could go from miles per hour to kilometers per hour. And so anyway, my son riding along with me one time, he goes, "Mama, Daddy was driving down boat lane at 120 miles an hour. Can you believe that bass boat will do 120 miles an hour?" And I was running about 60, but the things are relative, and the kid, that was a big deal, and he thought that was the truth for a long time. I finally had to straighten that out. I got, no, it's set on kilometers, because it would run. It wasn't the 17-foot 9-inch bass boat, and it would get up there, and people have big motors, because my motor said 150 on the caliper. Okay, and so they'd have these brand new 4-stroke whatevers, and when they came out, and a little 2-stroke just 1978 boat, and, blowing their doors off, and but yeah, I've had fun with technology just because I knew something that they wouldn't tell you, and I was real fortunate coming up through aviation. And when I say aviation, I started off with little model airplanes, and they got bigger and bigger and bigger, and that was an expensive hobby. My dad raised 4 kids, and he supported me doing those things as far as helping me and stuff. But man, some of that stuff was big ticket items back in the day. And so I was mowing yards and throwing papers and collecting bottles and turning them in, and just anything I could do to get enough money for my next project in that area. And in 1967 and 1968, I was 10 and 11 years old, and I won the Southwest Region American Model Association half A speed competition with my model airplanes, and I designed them from scratch. They weren't kit planes. These were planes I drew up from my own mind and souped up the motors on them, and I was going against guys our age. So I learned 2-stroke motors actually from little 2-stroke 049 engines, the thimble drone, all the way up through Enya and McCoys and Fox. And man, I'd get that motor and figure out what was going on, clean it and polish it, and learn how to use pressured fuels and how to pressurize the unit. And the point is that I was a little sawed off sucker and going against guys our age. What's going on there? And so they picked my brain pretty good, and they trying to figure out what I was doing so they could run with me. And did the same through go-karting, and started off running sprint track, and then ran enduro, and the same thing. Now the thing was, I was a pretty big little boy. When I was in grade school, I weighed 90 pounds, and a lot of the guys that I was running against in my heats, they were a lot lighter, and so I was usually always overweight as far as size for the carts and stuff. And it really frustrated me because I'd be running against kids that didn't weigh 60 pounds, and same motors when I was running stock, and they just beat my ass, And one of the guys that got me started in that, his brother, Steve, was one of my best friends, and Steve, he didn't weigh nothing, and here I am, big old boy, and his brother was sharp. Robert was sharp, is sharp, and but it frustrated me, and man, I did studying, and when I started modifying my motors, and put the same technology that I did from the motors from my little model airplanes into that. Well, then the people started talking to me again. They go, "What are you doing? You got more power there." And so there's tricks to the trade. A lot of those old timers knew. One of them was we had a guy that you take a stock motor to, and he'd hydrogenate the block. And a lot of people never heard of that. And and he wouldn't show the process, but all we knew is we put the motor back together, and you had more horsepower there. And in racing, if you have 1/10 of a second over somebody, you win. That's it's pretty simple. Just a little edge, and it was legal. I mean, if they probably found out what it was and they understood the technology, they would have probably said something. But he'd hydrogenate the block and run stock, and there was a different stock motor. So those guys running those classes had 2-3 more horsepower for what they were running. And when you're running in the 11, 12, 14 horsepower range, that's a lot. And so anyway, the thing that happened was I helped one of my grade school friends build his model airplane up. I got kind of chasing a rabbit, but I helped him build his model airplane up. His dad called me on the phone. He was a flight instructor. And he said, "I want to thank you for helping Greg build his model airplane up." He said, "Would you like to fly the real thing?" I said, "Yes, sir. I sure would." And so anyway, he soloed me when I was 14. His son, the guy I helped build a model airplane with, he didn't really care about flying at all. And so I was his buddy flying. And anyway, back then, you could solo with much earlier, and so I've been a solo pilot since I was 14. Then went through and later on, but did a lot of flying until I got married, and then I put aviation on the back door and raised a family, and then got to pick it up again later on in life, and whole lot of water under that bridge. But I have a passion for aviation. So any of you pilots out there that just like to talk about that, and don't get me started on that, because I ended up building control surfaces and the different technology. Man, they have some really nice airplanes coming out now that are really neat. So, don't know that I'll get back into aviation like I was, but I see a possibility for this technology to build electric motor power. And I am shooting for about 180 horsepower in the runtime for about 6 hours. And I found out real quick when I started getting over 22, 23 horsepower with the electric motor. And the way that I do it is on a dyno boat shop. I have a dyno, and it's a hydraulic dyno, and so I can put that torque on there and get a pretty good idea of what that's running and RPM and load. But anyway, I hit the wall about 22 horsepower. One thing I can tell you that there's power in and power out, and the amperage when you're designing those type motors, you have to design your motor to handle the amperage on going through it. Then controlling it with voltage is very easy. But to give you an example, if you have 10 horsepower, that's 7,500 watts of electricity. Okay. And in the asymmetrical motor, I can build one that is a constant 10 amps. Okay. And I demonstrated how to control it. But the problem that we're having is that in an asymmetrical motor, it's a mogen situation. I call it metronomic because when it runs slow, it sounds like a metronome. And the return voltage on the mogen, when you may start off with, let's say, 36 volts. Okay, that's your input energy, and you're drawing 10 amps. Okay, so then you're controlling the rest of it with voltage. That return voltage is coming right back to the battery post. And when it gets over a certain amount, then it's over. Anyway, I've got to get to work. My phone's ringing. So hope you guys have a blessed day, and I'll talk to you later.